Hello everybody, this is Miss Lindsay. Today we're going to talk about two formulas used to find the area of a triangle or any figure when only the coordinates of its vertices are known. So please pause at this time. I would like you to read through these 4 steps. This method is what we call the shoelace method. So pause the video at this time. Please read through these 4 steps. I'd like to point out 2 important steps before we actually move on to the first example. Number 1, list the ordered pairs of the vertices in counterclockwise order, repeating the first ordered pair at the bottom of the list. So you can see our example over here to the right. They started with 5, 7. They went counterclockwise all the way around the figure, and then they repeated the first order pair. Very important. Okay, then they took the downs, they multiplied the downs, so it's making this shoelace pattern over here. They took the downs, multiplied those all together and added them. Then they took the up diagonals, again making that shoelace pattern, multiplied and add them together. And then the formula is 1/2 down minus the ups. Now if you accidentally forget to do the counterclockwise order, another formula, it's the exact same formula. In some textbooks you'll see the absolute value of the down minus the ups. That way if you get the negative value, you take the absolute value of it, and then it should still be the area of the figure. But again, if you remember to go in counterclockwise order, you will not have this problem. So let's go ahead and take a look at the first example using the coordinate method, or what we call the shoelace method. Okay, so we have the ordered pairs here, 3, 7. The next one is 1, 1. And the third one is 8, 2. So we'll just start, doesn't matter which one you start with, we'll start with 3, 7. And then we're going to go in counterclockwise order. So we'll go 1, 1, 8, 2, and then repeat the first order pair. Now we're going to do the downs. So the downs are 3 times 1, 1 times 2, 8 times 7, so for a total of 61. And then we'll do the ups, 3 times 2, 8 times 1, and 1 times 7, for a total of 21. Therefore, the area would be 1/2 the absolute value of the downs minus the ups. And again, if we've gone in counterclockwise order, we do not need to do the absolute value, but 61 minus 21, so 1/2 of 40, which gives us an area of 20 units squared. Taking a look at our second example here, again, let's go ahead and find the coordinates. We have 3, 7, then we have 1, 1. Our next one is 8, 1, and last then we have 4, 3. Going through the same approach, I'll go ahead and start with 3, 7 again. Going counterclockwise, 1, 1, 8, 1, 4, 3, and again repeating the first order pair. We'll do the downs, 3 times 1, 1 times 1, 8 times 3, and 4 times 7, for a total of 56. At this point in time, I'd like you to go ahead and pause. Please do the ups and calculate the area, and check your answer when you are done. So again, calculate the ups and then find the area. Okay, so check your answer of 14 units squared on this. We're going to go ahead at this time and skip that last example. Please go to the back, where we're also going to use another formula to find the area of triangles. This one is using our matrices, and in particular our determinants. Remember, these, what it looks like absolute values, are actually refers to the determinant. Okay, so to find the area of a triangle have 3 vertices. Now we would take 1/2 the determinant of those vertices. We put those vertices in the first 2 columns, and the third column is filled with 1s. So let's go ahead and actually try problem number 4. Okay, so we'd have the area equals 1/2, and we will fill in our vertices in the first 2 columns, starting with 9, 4. I'll go ahead and still go in the counterclockwise order, and then our third column is filled with 1s. Go ahead and at this point in time, please pause, grab your graphing calculator so you are can enter in the matrices into your calculator and figure out the determinant. So pause at this time, please. So using your calculator, if you go to second matrix, go over to edit. This is a 3x3, and pause the video at this point in time and please enter in the matrix. Once you've entered in your matrix, if you go to second quit, get back to your home screen, go back into second matrix, go over to math. Number 1, DET stands for determinant, and select your matrix again by going into second matrix name. So I put mine into A and enter. So we get the matrix, the determinant to be 32. So we get 1/2 32, which gives us the area of 16. Moving on to the next example, looking at number 5. So again, here we have area equals 1/2 the determinant, forming our matrix here, -1, 6, and our last column is going to be 1s. So I'm going to go in the other direction this time, and we get that to be 2, 4, 1 and 0, 0, 1. Let's go ahead, please, at this point in time, pause, calculate the determinant, figure out the rest of the area, and then push play to check your answer. So as you can see, I have calculated my determinant, and because I did not go in counterclockwise direction, I did end up with a negative. However, please remember that does need to be positive. It's because we did not go in the correct order. Therefore, the area of this triangle is 8 units squared. At this point in time, I would like you to go ahead and finish the examples on this page, which are 6 and 7. Go back and do number 3 as well, and then finish the attached worksheet for homework. This concludes section 16.2 notes.